Hello GameMakers, this is GameMaker Rob, and in this episode we'll be doing a scrolling background as seen in Nemesis or Gradius. Let's jump into it. So this is a video request from T. Jansen. The request was to make an example of how to create the scrolling terrain effect from the Nemesis or Gradius games. The requirements were it needs to be similar in style to Nemesis, make the environment scroll by itself from left to right, make the scrolling stutter so it can't be smooth, and we also need to have the ability to have randomized terrain. One thing I added as well was the ability to have terrain of different shapes and sizes. So I'm going to start by showing you the sprites that I'm going to use as I usually do. I've got a set of ground sprites. These are going to go on the bottom, and I've just made 4 different ones. They're going to be randomly generated as the room shifts to a new piece. The width of these sprites are 16 by 22. The width of all the sprites needs to be in increments of 16 for the code to work. And the height needs to be, it can be anything you want actually, the height. One thing we'll say is for the random generation to look okay, the edges of the sprites, like the height of where the last pixel is, needs to be about the same as where the other images end. Otherwise it's going to look very contrived. It's going to be very obvious that it's randomly generated. I've got a ceiling sprite with 4 images. These are just the reverse of the ground sprites. That's actually quite an easy effect to do. All you need to do is edit image, then click on image, and then flip, and it will flip all the frames like so. And I also included 2 larger images, a mountain for the ground terrain. It's a width of 48, height of 44, and a reverse mountain which is again the same width but a height of 64. The origin points for the ground needs to be from the bottom left for all sprites, including the mountain. And for the ceiling sprites, it needs to be in the top left, like so. Okay, we've just got a simple room as well. The room width and height is 256 by 192. We're not going to be using views or anything like that. The effect we're going to do is we're going to be using objects to display the terrain, and every few seconds the objects are going to move to the left. The one on the far left is going to be destroyed, and there's going to be one created on the right if needed, because the last object may be a mountain and we want to see the full mountain before we create a new object. And every time an object moves past the screen on the left, it'll be destroyed, so we don't end up with hundreds of different objects. I did try a few different methods of creating the scrolling effect. I started off with arrays, and I was going to split the game room into different squares, but I mean it works, but it's going to be further complicated as opposed to this method. So let's just jump into it now. So the first thing we're going to do is create a new object, call it OBJ Terrain Manager. This object is going to create all of our terrain. It's also going to make the scrolling effect and add any more terrain that we need. Create event, region, create initial terrain. sprite width equals sprite get width SBR ground. We're going to capture the base width of our basic sprites, because we want to know how many of those sprites we can fit inside the room, because we want to say hcells equals room width divided by sprite width. And just in case anyone's got the wrong room size, as a safety net, we're going to floor the value. All that does is gets rid of the decimal place. One thing I forgot to mention about the room is we do actually have a view just to enlarge the room. So I've got the width of the camera as 256 by 192, covers the room, and the viewport is 1024 by 768. Okay, so we've got the H cells now, and what we're going to do first of all is we're going to create a load of terrain objects along the bottom of the screen, and we're going to use a for loop for this. So what this is going to do is, say for example H cells is 16, it's going to create 16 instances of OBJ terrain. Every time it creates an instance, it's going to save that instance ID inside a variable called terrain piece. The reason we want to do that is because we want to access that actual piece by saying with terrain piece. So we're now inside the instances code here. We're going to say sprite index equals SBR ground. So we're going to give it the sprite index of sprite ground. We're going to set the image speed to 0 to make sure it doesn't cycle through all the different image indexes. And we're going to say image index equals irandom sprite get number SBR ground and a -1. Sprite get number is going to give us how many image indexes are inside the sprite. But if there are 2 images, don't forget the index will be 0 and 1. And we want to return a number between 0 and 3, which is what this will do. And what this does, cells times sprite width. So when cells is 0, it will create the sprite at the bottom left. Then when cells is 1, it'll create the next object 16 pixels to the right of the first one, and so on and so on. This for loop saves us a lot of time. Otherwise, we'd have to type like 16 of these and do all this for each one. So this is a good example of when to use a for loop. Yeah, let's run the game. Or actually, let's first put OBJ Terrain Manager in the room and create OBJ Terrain. There we go, it turned red. Let's run the game. What did I do? Oh, I know. For the Y, we should be doing room height at the bottom. They were all created at the top then. There we go, we have our first set of randomly generated terrain. So the next thing we're going to do is we're going to make this terrain move. How we're going to do this is in the step event of our terrain manager. We're going to make the terrain move. So we'll have a timer called terrain timer. What plus plus does is just increases the value of terrain timer by 1 every step. It's the same as doing this. So we're going to set this to room speed. I know that I said before that you need to keep the width of the sprites at 16. That's not necessarily true. For example, if we change the shift rate to 8, then the width of your sprites can now be in multiples of 8, because it's this that determines how far the terrain is going to move to the left every 30 steps. Okay. So what this code does is, when the terrain timer reaches the time that the terrain should shift, which is set to the room speed, then this time we're using with statement to access every instance of obj terrain. So all the ones at the bottom, they're going to be affected by this line of code. We're setting every instance of that object, their X, to the shift rate of our terrain manager. To access the variable shift rate, we have to use other, because if you remember, this block of code inside the with statement it's like writing something in the step event here, and we couldn't just type shift rate in here because we haven't assigned it, we haven't created it. I think we are good to test the game. Let's run the game. So what we should see now is we should see all the objects move to the left. I want to change the shift rate to 16 as well, just to make it faster. There we go. The terrain starts to move. Obviously, we haven't created any new ones. All that's happening is every instance of the object we've got is just forever moving to the left now. So the next thing we should do before I forget is, inside obj terrain, inside the step event, is once it has disappeared from our view, we just want it to be destroyed. So we're going to say if X plus sprite width is less than or equal to 0, instance destroy. So we want to use X plus sprite width because the width of the sprite might not always be the same. For example, if we're using the mountain sprite, the width of this is going to be 48 and the ground sprite is 16. And very quickly, if we go into the draw event of the terrain manager, region, bug fix, And what we're doing is we want to see exactly how many instances of OBJ terrain are active. If you check out the manual for instance number, this is what it says. Let's run the game again. Make sure it's working properly. As you can see, every time it shifts to the left, an object gets destroyed. This is just to make sure you don't end up with hundreds of objects, like 1,000 pixels to the left or more. Awesome. We're just going to leave this bug fix on for now. When we're done testing, we just need to comment it out like this and change it to off, just so we don't lose it in the code somewhere. Okay, so now it's time to create new terrain pieces. If you go back into the step event of the terrain manager, inside the bit where we're making the terrain move, I'm going to say create new terrain if needed. Okay, so we're going to need a new variable here. We're going to create it in the create event. We're going to say last terrain piece equals terrain piece. What this is going to do is the very last instance of OBJ terrain that we create at the start, the one on the far right, is going to be saved as the last terrain piece, because we want to track how wide the sprite of this last piece is, because as soon as that piece is fully showing on the screen, we then want to create a new piece of terrain. And don't forget the width of this sprite for this piece of terrain can be different. This is why we need to check it. So if last piece dot x plus last piece dot sprite width is equal to the room width I'm going to say actually let's just copy this bit here. So if last piece.x plus the sprite of that is equal to the room width, then create a new piece of terrain at the bottom. Assign the index, assign the sprite with a random index. And what we need to do then is last piece equals terrain piece. And we need to change this actually as well to room width. Yeah, there we go. So this new piece is going to be created just off screen, because our sprites are drawn from the far left. Okay, so let's just run the game, and we should see a constant flow of terrain pieces. Oops, what have I done wrong? Oh, this is why. I called it something different. And there we go. A constant stream of terrain pieces. We're never going above 17, which is exactly what we want. Okay, so now we have this, we want to introduce the possibility of having larger pieces. The way we are going to do this is, let's have a look. So inside this with statement, we're going to say roll equals irandom 9 plus 1. Will give us a value between 1 and 10. And we're going to say if roll is less than 10, then sprite index equals SPR ground. Actually, need to include this as well. Else sprite index equals SPR mountain. That's it. That's what we need for that one. Let's run the game. Actually, let's speed this up. Let's change the time till shift terrain to room speed divided by 4. And there's our first mountain. A second one. You'll see the amount of terrain pieces gets lower whenever there's a mountain, just because it takes up 3 times as much room, which again is exactly what we're after. Alright, so now we've got that in place, it's going to be pretty easy just to add in the ceiling. So back into the terrain manager, the create event. So inside this for loop, that's the best way to do it. Yeah, let's just add another line, copy this line, paste it here. We'll call it ceiling piece. And the X coordinate can be the same, but the Y coordinate needs to be 0. Depth 0, OBG terrain, and copy this, paste it, with ceiling piece. Needs to be SPR ceiling. Change this as well. And we need a copy of the ceiling piece. And back into the step event. We're going to have a copy of this. So let's just ground piece. I'm going to copy this. Paste it here. and last terrain piece becomes last ceiling piece. And just change everything, like the sprites, name of the sprites and the variables. That's all we need to change really. Oh, and sorry, the y coordinate needs to be 0. This one. Okie doke, so let's just expand this. You should end up with something that looks like this. Let's run the game. And there we go. A scrolling background, just like Nemesis or Gradius. I hope you guys enjoyed this episode. If you did, let me know. If you want to see more videos on how to make this kind of game, let me know in the comments, because when people do request videos, I do try and get them done. That's it. I will catch you next time. Bye for now.